Hello, everyone. Welcome to today's webinar. This webinar is a presentation of Clean Energy Group, and the topic for today's webinar is a climate resilient energy code for multifamily affordable housing. And we have an excellent guest speaker with us today, but before I pass it over to them, I'd like to go over a couple of webinar logistics. All attendees are in listen-only mode, so your webcam and microphone are disabled, as well as the chat function. You can submit questions and comments via the Q&A panel. We will be saving about 10 to 15 minutes at the end of the webinar to answer all of your questions. So please feel free to submit your questions throughout the webinar, and they will be addressed at the end. Automated captions are available using the CC button. Speakers' bios will be made available in the chat. And finally, this webinar is being recorded. We will email you a webinar recording within 48 hours, and it will also be posted on CEG's website at cleanegroup.org/webinars. And with that, I'd like to pass it over to our host for today's webinar, my colleague, Seth Mullendore.
Thank you, Zareen, and thank you to everybody joining us today. It looks like we got a great crowd on the line. So excited about that. So just as a quick intro for those of you that are less familiar with Clean Energy Group, Clean Energy Group is a nonprofit. We work across the country with the goal of enabling affordable, reliable, clean energy for all. We work across a number of different areas, including climate resilience and community health, distributed energy access and equity, energy storage and flexible demand, as well as accelerating fossil fuel replacement with clean alternatives. So on the next slide. Today, we're going to be talking about climate resilient energy code. We've got a draft code. There's a draft Connecticut climate resilient energy code. There's a link to it there. I think we can drop the link in the chat as well, so that folks have direct access to that. And we'll get into that in just a minute. Next slide, please. Great. So joining me today is also Tristan Grant. He is Associate Director of Codes and Policy at New Buildings Institute, one of our partners on this project. So with that, Zareen, if you could pull up my slides, I'll get into the presentation. The first thing I'd like to do is just give you a little bit of background on this project and how it came to be, how the codes came to be, and what we're talking about when we say a climate resilient energy code for multifamily affordable housing. So start off, what even is a climate resilient energy code? What does that mean? Well, I'm sure lots of folks would have different interpretations of this, but when we got into this, the goal was really to design a code that would enhance a building's ability to continue providing essential services to residents: clean heating, cooling, fresh air, access to clean water, access to plugs for powering devices like medical devices, charging phones, refrigeration, as well as maintaining comfortable conditions. So things like temperature and humidity levels within a building so that occupants were able to shelter in place more safely when there was an emergency, particularly when there was a power outage during severe weather. So the results of this are improved comfort for everyone within the facility, increased safety during emergency events and power outages, ideally also reduce costs, because it incorporates cost-saving measures as well: efficiency, solar and battery storage, and peace of mind. This provides resilience and energy security to everyone on site. Next slide. I don't think I have control here yet, Zareen. So this project that we're talking about today is part of a federally funded project that is being supported by the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy under their Building Technologies Office. This is the official name is Climate Resilient Energy Codes for Multifamily Affordable Housing. It's a 3-year project. We're about a year and a half in. Clean Energy Group, we are leading this. We're the prime on the work. We have a great team. Most of the work is taking place in the context of Connecticut. As you see, the draft code is Connecticut. As far as our Connecticut partners go, we have the Connecticut Green Bank, the Connecticut Department of Energy and Environmental Protection, and the Connecticut Insurance Department, as well as Operation Fuel, who is a nonprofit based in Connecticut. They do a lot of work on fuel assistance programs and outreach and help with communities, and the Yale Center on Climate Change and Health. On the code side, our codes expert is New Buildings Institute. They're the ones that drafted the code. And on the technology side, particularly solar and energy storage, technical partner is American Microgrids Solutions. All right. So I want to walk you through just how we got here to the code. So the project, as I said, we're about a year and a half in. We had the project launch back in October 2023. One of the first things we did was we reached out to stakeholders, and we established 2 advisory groups to oversee the process and help provide feedback and guidance throughout, particularly at critical points in the development process. So we have 2 advisory groups. One is affordable housing focused, so it's affordable housing providers, folks that finance affordable housing, resident advocates, and others in the affordable housing space. Then we have a technical advisory group. This is both like technology focused technical, as far as the building technologies, as well as those that are experts in the policy and regulatory side of things. And those advisory groups have been immensely helpful and a great part of the development process. So the first things that we engaged in is stakeholder engagement. We talked to dozens of folks across the affordable housing and energy sector, and to get a sense of what does energy resilience mean for them in the context of their work. What have they experienced as far as power outages go? What do they think should be prioritized when we're putting together this code? What should be in it? What shouldn't be in it? What concerns do they have? What barriers might we run into? And what already exists that we can build upon? The other part of that, which was led by New Buildings Institute, was a landscape review to get an assessment of what's out there as far as the codes and regulations that are already out there that we could build upon, borrow from, add to. We didn't want to replicate things that were already out there. So we got a very good sense of what was out there and what could potentially be drawn from to do the code that we're putting together. So next in the process, well, ongoing, actually, I should say that this project here was built upon work that had already been done with Connecticut Green Bank, Operation Fuel, Yale, and Clean Energy Group over a couple of years to get a better sense of the role of what we called climate smart technologies, solar, storage, efficiency, specifically for medically vulnerable affordable housing residents, those that are dependent on electricity for their medical needs. So Operation Fuel in Yale conducted interviews directly with affordable housing residents and support staff to understand their needs for public health and their concerns about power outages, and get a better understanding of what resilience means for them and what their dependencies looked like. We really learned a lot through this and kind of broadened our definition of not just medical devices that need to be plugged in, necessarily like a CPAP machine or an oxygen concentrator, but things like cell phones that have monitoring apps on them, wearable devices that people have that put them directly in contact with their health provider, things like mobility devices, electric wheelchairs, beds that folks need electricity for, elevators as well to be able to get around a building. So that culminated in a report that was released in August. We used all the information that we had, as well as that engagement with affordable housing residents to put together straw man concepts. This is New Buildings Institute led this as well, put together basically a list of all the things that we could include in the code, why it would be included, what that would look like, to share with our advisory group members and the project team to narrow it down for what we were going to include in the draft version of the code. So throughout that process, we got feedback, refined that, and that resulted in an initial version of the draft code in November of last year. And part of that process and a part of making sure that we had taken the resident feedback into consideration with the straw man concept and the draft code. Operation Fuel engaged in another round of engagement with affordable housing residents through a number of listening sessions. There was a report that was released in March that has the takeaways from that. After I hand things over to Tristan to dig into the content of the code, I'll circle back to this to give you a little bit of an idea of the results from that. This is available on our website, as are the other reports. Also, we did, using the draft code and the measures, we did a number of impact analyses to look at the energy usage impacts, the cost impacts, as well as the resilience impacts of these measures. I'll return to that after turning it over to Tristan to give you a little bit of a glimpse on that. This report, again, is available on our website. We released that in March, along with the release of the public version of the code. So that is available, I think, as Irene said, in the resources that we have for this, as well as the link to this. It's linked to this page for the code, along with those analyses. So this is the draft code that we have out right now, and we are looking for public comments back on that. Would love for you all to chime in. We want to hear from you. I'm going to return to that in a few minutes after I turn things over to Tristan, which I will do right now. So New Buildings Institute, they were the author of this on behalf of and with input from the rest of the project team. All right, so we'll get Tristan's slides up and he'll dig into more of the details of the code itself.
Thank you very much, Seth and Zareen, and thank you all for joining us today. As they mentioned, my name is Tristan Grant. I'm an associate director with the New Buildings Institute. I oversee a number of our projects related to stretch and advanced code development and resilient code development nationally and here in the Northeast. Next slide, please. So Seth got into this a little bit, but the intent of this code and this project is to develop a climate resilient energy code that focuses on resilient energy systems, renewable emergency power for those systems, to power essential services for multifamily affordable housing residents during grid outages, and specifically during grid outages in extreme weather events. We want to allow residents to safely shelter in place, and this has direct and tangential benefits of improved health and safety outcomes in the form of habitable conditions and tangential benefits of improved regional air quality by reducing on-site emissions and associated energy consumption emissions, and increases energy affordability. Next slide, please. Resilience. One definition of resilience is the capacity to withstand or to recover quickly from difficulties. And so when we're talking about this in context of the built environment and our buildings, we're really talking about buildings' capacity to withstand and maintain conditions during a range of exterior environmental conditions. So maintaining habitable interior conditions during a range of exterior environmental conditions. A lot of resilience elements are already baked into the International Building Code. We're talking about providing reasonable levels of safety, health, general welfare, temperature, thermal control, and response to some hazards, including fire. So this is not necessarily a deviation from the intent of existing building codes, so much as an expansion of that. Next slide. It likely comes as no surprise to all of you that we are facing increasingly unpredictable and turbulent environmental and climatic conditions. We have, over the past several decades, seen an increasing severity and quantity of very expensive billion-dollar climate disasters. Next slide. And these are resulting in more consistent power outages. So you can see here over the past several decades, the number of power outages affecting 50,000 customers or more from Connecticut went from early in the century, none in the course of a year to pretty consistently multiple 50,000 customer outage events. So this is the context that we're designing a resilient code for. Next slide. The framework of this code was structured as an overlay to the international residential, international building, and international energy conservation codes. These touch both the residential codes as well as the commercial codes. Any multifamily buildings that are 4 stories or more get permitted under the commercial energy and building codes. And so there's 2 parallel, the code is structured with 2 parallel pathways of amendments that impact both commercially permitted residential buildings and residentially permitted residential buildings. We have not gotten to the ASHRAE amendments yet, but we do plan to create another parallel set of code amendments that cover ASHRAE 90.1 and commercial buildings that follow that energy code pathway. In addition to this, there are some guides and resources that will be published with the code to help project teams understand and navigate this, including resident manuals. Next slide. So the framework of this and how these amendments show up in the draft code is broken down into 3 primary categories. Moving from right to left, we have improved envelope code measures, and these are covering largely passive measures that improve the thermal comfort and operating efficiency of the building, such as opaque envelope improvements, improved glazing requirements, improved air leakage requirements, and prescriptive thermal bridge mitigation approaches. Going to the center, we outline requirements for emergency power, and we outline requirements for the systems that these emergency power systems serve, such as heating and cooling, ventilation, and electrical circuits, and where those are provided either in dwelling units or in common spaces. And then on the left, we have additional resilience measures, and we included urban heat island mitigation requirements and requirements for emergency management procedures manuals that are provided to building operations staff and to residents. Next slide. So starting with the improved envelope, we felt, and the technical advisory groups and the project team felt that it was appropriate to start with passive measures because this increases the ability of buildings to provide habitable conditions for a prolonged period of time before we even get to emergency power sizing and emergency power for critical systems. And so we drew heavily on Passive House as inspiration and as reference for this, and looked at Passive House approaches to opaque assembly R value and U value specification, improved glazing systems, improved air leakage, and thermal bridge mitigation. Next slide. There's been a lot of research that shows how the Passive House standards perform in a range of environmental conditions, and research into the cost. And we're really talking about relatively small incremental cost increases that have a pretty significant impact on a building's ability to maintain habitable conditions. That helps in the event of a power outage. That also just helps conserve energy and conserve cost during normal operations. Next slide. Okay, this slide's got a lot going on. What this is showing is research that existed before we started our project, but that we leaned on and looked to heavily to justify why Passive House is an appropriate place to look to for code requirements. And what this is comparing is Passive House and ASHRAE buildings modeled to the Passive House standard, buildings modeled to the ASHRAE code standard, and how those buildings are able to maintain temperature over a period of time during a simulated grid outage. They have this at different orientations of the building and different window to wall ratios. If you can click 3 times. Yeah, twice more. There we go. Okay, so looking at this for 2 orientations and at 1 temperature difference, you can see the top 2 red rectangles highlight the southwest orientation, Passive House, and ASHRAE buildings at 20% window to wall ratio and it shows the percent of hours during a 7-day simulation that are above the temperature threshold. This temperature threshold that has the blue rectangle around it is 50 degrees Fahrenheit. And you can see during this simulated grid outage, the passive house building had 95% of the hours above 50 degrees. The ASHRAE building had 42% of hours above 50 degrees. That's a pretty significant difference. And we're seeing something similar with the 60% window to wall ratio with a northeast orientation, about a 40% difference in the number of simulation hours that are above that temperature threshold. Next slide. And so when we went out, Pacific Northwest National Laboratory was also a partner on this project and helped us establish some metrics by which we evaluated the performance of our code, the passive performance of our code. We looked at standard effective temperature, which is a metric that incorporates a number of conditions into a temperature temperature value to represent interior temperature conditions and how people experience that. We set the thresholds at 54 degrees for heating and 86 degrees for cooling. This is based on a LEED pilot credit that establishes a maximum number of set degree hours that a project needs to stay below during a simulated grid outage event in order to qualify for the LEED credit. And this is just one way that we were evaluating the improvements to the passive building envelope design for our code. And we looked at this. We looked at model prototype buildings for low rise, mid rise, and high rise under 3 and 7 day simulated grid outages during extreme heat and extreme cold weather events to see how the passive measures performed. Next slide. Next slide, please. And what we saw, this is just a snapshot. We have dozens of these modeling results, images and graph results. But what we saw is that for the cold event, we were significantly prolonging the period of time where the building would stay below the set temperature threshold. And this was at a very marginal, small penalty for the heat event. And the reason for that is that it turns out when you increase insulation significantly, decrease air leakage, and optimize the envelope for a cooling or for an extreme cold scenario, there is some penalty on the extreme heat scenario because you're holding all of that heat inside the building. Next slide. Next slide. And to look at that in a little more detail, can you click a few times? I think I've got a couple more boxes here. Yeah, here we go. Looking at the mid-rise, high-rise, and low-rise for the 3-day event, there was a reduction in set degree hours that were over in set degree hours by 94%, 54%, and 34% respectively. And you can see on the extreme heat side, there was a 10% penalty for the mid-rise and a 21% penalty for the low-rise for the extreme heat set degree hours. We were not too concerned about this for our code because you can see the set degree hours in the extreme cold scenario were higher than the set degree hours for the extreme heat scenario in all cases, which means that when it comes time to use this information to size the emergency power systems to provide power for critical systems during a grid outage, the extreme cold scenario is still going to be the design case, meaning that's our worst case condition that we're designing for. And so even though there's a slight trade-off here, we are not, this shouldn't drive cost in the sizing and the provision of the emergency power system. Next slide. Alrighty, so moving on from the passive envelope improvements, we get to the emergency power for critical building systems. We defined critical building systems as heating and cooling, ventilation, and emergency circuits. And we look at 2 approaches to providing those in a building. one where you provide those in all of the dwelling units, and one where you provide those in common spaces. Next slide. So yeah, I mentioned heating and cooling, ventilation. The electrical circuits include outlets for medical devices and other devices, as well as power to pumps, where pumps are needed to deliver potable water to spaces in the building. And we looked at two pathways for how a project could comply with these requirements. One is where they provide emergency power to emergency heating and cooling systems in dwelling units, and one where they set aside a certain amount of space in the building sufficient to house all the occupants in the event of a grid outage, and they provide heating, cooling, ventilation, and emergency circuits to that space, similar to a cool or warm room approach. There's various literature, resilience research on that approach. And in both cases, we require a minimum amount of space to be set aside per occupant that has heating and cooling and associated systems, service from associated systems provided to it. Next slide. So the way that this language kind of flows down in the code is that we say you have to provide emergency power to distributed heating and cooling systems, or to heating and cooling systems, either distributed throughout the building in all of the dwelling units, or in a common space with I think 20 or 30 square feet per occupant, so that there's sufficient space to house everyone. The requirements then flow down from that, where emergency power is provided to heating and cooling according to that previous code section. You also have to provide ventilation, and you also have to provide emergency circuits. We then say that the load duration, the sizing of the emergency power system needs to meet a load duration of 24 hours. And we have some allowances for how that sizing is calculated, because we also have certain controls requirements for the systems that are backed up. Next slide. So for heating and cooling, we require smart thermostats and smart controls that are capable of automatic temperature setbacks in the event of a grid outage. For ventilation, we're requiring balanced energy and heat recovery, and we also require smart controls that are capable of automatic airflow reduction in the event of a grid outage. And for emergency circuits, we require load shedding capabilities if additional loads are backed up beyond those that are minimally required. The main idea here is that we want to make sure that we're able to prolong and extend the period of time that emergency power can be provided as much as possible. And so, optimal interior temperature conditions are not necessarily the priority. The priority is habitable conditions. And so we want these systems to be capable of automatically setting back, reducing airflow, reducing energy usage during a grid outage event, so that we can provide habitable, livable conditions for as long as possible. Next slide. I'm not going to get into this too much, but the American Microgrid Solutions, the solar and storage and microgrid consultant, took the energy modeling results that PNNL helped us with and took the output of that and did a number of scenario analyses with solar and storage sizing to come up with some cost-effective solar and storage design sizing criteria that we incorporated into the code. We set minimum solar and storage provisions based on this, but if those alone do not meet the sizing criteria, we do allow for hybrid systems. And the sizing criteria for the emergency power system is allowed to be calculated using the reduced loads based on the smart and dynamic controls that we require. Next slide. Alrighty, so moving on to the other resilience measures. Next slide. The project team and stakeholder groups felt it was appropriate to include urban heat island mitigation criteria. Extreme heat is a leading and growing natural hazard. It's a leading natural hazard cause of mortality. It contributes to lost worker productivity. It's associated with adverse health outcomes and adverse health costs. And it disproportionately impacts vulnerable populations. And on top of all of that, it has a direct impact in how much energy buildings use for for cooling during an extreme heat event. And so it's what we felt it was appropriate to include those measures in the code to help improve performance during extreme heat events. Next slide. And lastly, we set requirements for the development and provision of emergency operations and management procedures manuals that are developed and provided to both the ownership to deliver to building operations staff, but also specific manuals for the residents to understand how their behavior, how their decisions, how they operate the building during a grid outage has an impact on how long the systems and the emergency power systems stay on during a grid outage. And so this is reflecting the role that behavior can have on real world performance in a grid outage event. It also provides best practices for emergency management of building systems and also resources to community networks and things like that that can help community members respond during extreme weather events. And I think that's it for my portion.
Great, thank you, Tristan. I've got just I think 3 more slides here to go through before we open it up for question and answer. I'm just going to briefly touch on the additional reports that we put out with this, the preliminary impact assessment results. So in order to get a sense of how the implementation of this code actually would impact buildings in practice, we worked with Pacific Northwest National Lab, as Tristan mentioned, to specifically, we looked at a deep dive at a mid-rise apartment in Connecticut. So a 30-unit representative mid-rise apartment building, 3-story, to look at what the resilience impacts would be, the energy usage impacts, and the cost impacts. So based off of the specifications in the code, this ended up in a system size that was 46 kilowatts of rooftop solar and a 60 kilowatt, essentially a 4-hour duration battery system, 246 kilowatt hour battery system. And this system for this representative building is able to provide backup power at a minimum of 26 hours. A minimum means worst case scenario. So this is when we don't have solar to help offset some of the load, and we've got higher loads. So that's the worst case scenario. Typically, if an outage occurred at any time throughout the year, it'd be able to provide about 59 hours, so more than 2 days of backup power under typical conditions. As Tristan already went through, we saw a marked increase in the building's ability to maintain habitable temperatures during extreme cold events. That graph there on the right just shows the yellow line is the base case. And the base case for this is that same building meeting the current code requirements that Connecticut has in place. And then the green line is implementing the measures in the climate resilient energy code. So you can see on the yellow line, after about 4 days in an outage, it goes above that threshold, that set degree hour threshold that Tristan was talking about, where this is deemed to not be a habitable building anymore at this point. It's become, in this case, it was extreme cold, so it's too cold for residents to really shelter there and have it be healthy conditions. For the climate resilient energy code, after 6 days, it did not cross that threshold. This varies from apartment to apartment, but overall, as a building, it maintained habitable temperatures. On the energy use, there was a bit of a trade-off here. The solar clearly offsets some of the grid energy use, the electricity consumption, whereas the energy storage, due to just the parasitic loads of keeping the battery operating and some inefficiencies in charging and discharging, it resulted in about a 9% reduction in electricity consumption throughout a year. On the cost, we looked at two different scenarios here, which had very different results. One is a master metered building. So that's a building where all the common areas and all of the apartment units are on a single meter. The residents themselves don't have individual utility bills. So for a master metered building, over a 20-year lifetime, our analysis lifetime, the internal rate of return was about 6%, a little less than that. So positive IRR. And then the net present value was a little bit negative, negative 900, but it's basically a break even over that time period for the cost, the upfront cost of installing all of these and maintaining them versus the bill savings and revenue through participating grid services and incentives that are out there. It was quite different when we looked at an individually metered building. So individually metered, the common areas are all on one commercial meter, and there are individual residential meters for every apartment building within the affordable housing building. For that, we actually saw a negative internal rate of return of 6.8% and a negative net present value of $123,400 over that 20-year term. So quite a bit different. The reason for this, there's a couple of things. One is the way that incentives are structured in Connecticut. So the solar incentive for individually metered, 20% of the generation from the solar has to be allocated directly to offset the cost of resident utility bills. So that's an important difference here, where 20% of the solar production lowered bills for individual apartments, saved residents money. Whereas in the master metered, because they don't pay utility bills, that 20% value gets reinvested, which could go towards an investment in a battery storage system. So it offset that cost. Also, master metered had more ability to reduce some of their demand-related utility charges, just because they had higher utility bills, having more on one meter. The impact report gets into all the details of that. Doreen, if you could go to the next slide, please. The other thing I want to touch on is the resident listening sessions. So I believe there were 8 listening sessions that Operation Fuel conducted. There were 80 affordable housing residents in all that attended these sessions. And this was to really educate them, provide information about the code process, what was going to be included in it, and get feedback from them about any questions they had, concerns, things they felt that weren't being covered. I highlighted a few of the quotes from this. The first one from a New Britain participant, New Britain affordable housing property. Everything we're discussing here in structure and envelope is a product of my building right now. It's under city investigation. Everything we're talking about here is what I'm going through in that building. Basically, what this resident was saying was they were living in conditions that were suboptimal. It was drafty building, there was mold, there was a lot of conditions that measures included in the Climate Resilient Energy Code would help address. A tighter envelope and better living conditions overall. Just noting the issues that affordable residents are already having with buildings not being up to code. A New Haven participant noted that you're going to have a hard time with the population here because so many people can't even use a cell phone. This was concerns about the technology, specifically energy storage and solar, not being able to provide the resilience that you need in times of need due to just uncertainties about technology and new technologies, not having a long track record and being able to perform. So some hesitancy there. Another New Haven participant noted, a lot of us can't even go down one flight of stairs. Most of us have disabilities of one kind or another. Again, highlighting the medical vulnerabilities that the population served by affordable housing often faces. A lot of residents have disabilities of one kind or another. Also, there's just not a lot of resources to be able to respond to or move to another location when there is a severe weather event and power outages. Lastly, from Hartford, changes will not be implemented in affordable housing because then it will no longer be affordable. We heard this from stakeholders across the board, from advisory group members, that if you implement this, it's going to make affordable housing too expensive, and it's going to increase the cost to provide affordable housing, and it's going to increase the cost to affordable housing residents to pay for it. This is something we are very considerate of and was very front of mind. You saw that impact on the individually metered buildings. So, you know, in our recommendations for implementation of this is making sure that there are incentives in place that can help pay for that additional cost. So my last slide, if you go to the next slide, this just talks quickly about next steps, and then we'll open it up to questions. Please enter your questions if you haven't already. So right now, as I said, we're halfway through this. So we've released the code and it's open for public comments through June 27th. I would love to hear from all of you. Please submit your comments, even if it's just on one little thing or something that you would like to comment on. It doesn't have to be long. And these can be submitted just as an email to comments@cleanegroup.org. That's also on the website where the code is. Once we have as part of that feedback process, we're also going to conduct another round of resident listening sessions. Now that we have the draft version of the code, we're going to go through and share that again and get resident feedback. We're going to take all of that feedback, revise and finalize the code language. Hopefully that'll be done by the end of 2025. We're also going to conduct updated impact analyses to look at more real world conditions for implementation of this code. And once we have the specifics of everything that is in that code. After that, it's going to be dissemination, engagement with states, municipalities, affordable housing providers. The ultimate goal of this is to get at least 3 affordable housing providers to commit to adopting and implementing the code at one or more of their properties. Actually, the first question that came in, and I should have mentioned this, this is not being developed as a requirement, and we're not expecting this code to be required nationally or even at the state level. It was developed as a voluntary stretch code. This was partially as a result of the feedback that we got from affordable housing providers themselves. Going back to that, this costs too much already, and we don't want to add costs to this. So we're developing it as a voluntary code. You know, our hope is that it might be also incorporated into some of the incentive programs or financing programs for affordable housing properties, so that this could be additional points that you could get in a consideration process to unlock, you know, financing or incentives or rebates that are out there. So that's the end of my slides. So we can stop sharing those. And yeah, Tristan, if you want to come back and join me, we will get into answering the questions. There's some great ones here. So I did answer that first one. Related to that, which I already talked about, is, you know, if this is required, will there be funding assistance opportunities? So like I said, that's why we're doing the cost impact analysis, and that is one of the goals for this, is to make sure that there is enough incentives and financing and everything that's needed to ensure that this is cost effective and can actually be implemented without raising the cost of affordable housing. So Tristan, I don't know if you want to weigh in on that at all.
No, I think you said it well, right? We're hoping to establish some of the price points so that if and where this is referenced by incentive programs and state programs, they understand what sort of financial assistance is needed to offset the costs and to justify the benefits for this. So yeah.
Great. And the question did come in about the funding. So this is federally funded. And the question was, you know, do we have any concerns about continuing to get reimbursed for the project, considering the uncertainty and some of the executive orders that have come out? I can say that, you know, the project work has continued. We are at the halfway point, so this is kind of the decision time where we'll find out if we get continued to go on to do the next year and a half of work. The work has been reimbursed, you know, and we are confident that it has met the objectives and the goals that were established. So we are confident that it is going to move forward, but there's a lot of uncertainty right now. If for any reason federal funding gets reduced or goes away, we are certainly going to be looking for other ways to continue the work and keeping it going. We don't intend to stop, but we may have to get creative if that comes about. But as I think everybody probably knows, there's just a lot of uncertainties right now. So we'll see where we go with that. All right. Question, who was in the advisory groups and how did you solicit their participation? We had a wide group of folks that were part of the advisory groups. So there were several affordable housing providers that were part of that. We had a couple of representatives from the Connecticut Housing Department. We had Connecticut Department of Administrative Services, as well as the Housing and Finance Authority. We had some technology providers that were part of that. We had some academics that were part of this. Some folks that represented municipalities, some municipal advocates and municipal membership organizations. We had the public utility, PURA in Connecticut, the public utility regulators, as well as representatives from Eversource, one of the big utilities in Connecticut. So it was a pretty broad group of folks that were part of the advisory groups. Every time we had a major decision, we met with them and shared. So, you know, every time the straw man proposal was a big point of feedback from the from the advisory groups. When we released the first draft code, we had a lot of engagement with the advisory groups then. So at every point along the way, we wanted to make sure that they were in the loop on this and get their feedback. We also did provide for those folks that requested some compensation for participation in the advisory groups as well. All right, so I think this one will be to you, Tristan. Person noting that they've read about the effect of extreme heat conditions on indoor air chemistry and certain activities that can cause worse indoor air quality for certain people. Was air quality a consideration or studied as part of this analysis?
It was more, I would say, adjacently. We did not specifically look at indoor air quality, and I think there's still a question mark about where and how the code comes down on all electric requirements. We did consider the impact of the on-site renewable energy systems on emissions and regional air quality and public health costs. And so what we did was look at for the sample system that American Microgrid Solutions costed out for the mid-rise prototype, we looked at the annual electricity production associated with that. We looked at the grid generation emissions offset associated with that, and we used the EPA COBRA tool, which is the co-benefits and risk analysis tool, to evaluate the public health cost impact of those decreased emissions. And so we did present that as part of our impact analysis and cost justification for the code. So there are a number of places that we believe that the code saves money. Whether or not there's a clear financing mechanism for how you leverage those public health cost savings to justify the upfront costs is a little bit more of an unknown. So no, we did not include the indoor air quality impacts, but we did consider regional air quality impacts of the code.
And I would say this is certainly a topic that came up in the engagement with affordable housing residents. There were a number of folks that talked about, particularly during a heat wave, how the humidity, how mold can affect asthma levels, can affect the health. I know there was a person that specifically talked about the health of their children and having to take extreme measures to make sure that they were able to continue to breathe. So next question, curious about why a low duration of 24 hours was picked as a best practice compared to some recommendations such as FEMA to have 72 hours of self-sufficiency. That is a great question. And Tristan, I would like to get to your input on this as well. This was a point of discussion, a lot of discussion among the project team and our advisory group members. You know, we did talk about a longer duration, like 72 hours. Part of the 24-hour consideration was a cost consideration, looking at the cost, particularly of battery storage, and having that be reasonable for the size system that you would need and the incentives that are available. So that was one of the big considerations. Also, just looking at outages that impacted Connecticut. Generally, they were shorter terms. I mean, there are exceptions to this, but that was generally the type of outage length that we were looking at. And the intent here wasn't to make this, you know, a forever solution. as much as we would like it to be. Some of the thought process was at least if you can give folks 24 hours, that's enough time, at least extra time, to figure out alternative solutions. So if folks are not able to manage it being on site, to look for alternatives. So that was some of the thinking. And Tristan, I would love to hear your thoughts on this as well.
Yeah, I would say this is also a pretty easy change within the code that's customizable based on local jurisdictional implementation and how this is being used in practice. And so if an AHJ or an incentive program or a project wanted to follow this standard and instead say 48 hours or 72 hours or 7 days is a more appropriate sizing criteria for us, that's it's one location, and that's the type of thing that we're going to have kind of supporting implementation guides to work with stakeholders who are interested in understanding and implementing this code. Like, hey, if you would like to adjust this, this is where you change that in this language, and these are the other things that would need to be changed. As Seth said, extended that sizing duration significantly increases the cost of a solar and battery system that can provide that. So if you're allowing hybrid solutions, you need to understand that that's probably going to be driving projects towards gas generators. And maybe that's the solution. Maybe that's the answer. Maybe that's what we should be doing. But those are some of the considerations. And so when we were looking at this, we were really looking at criteria for renewable energy systems. The second question here, how are emergency outlets and circuits communicated to multifamily residents to use? That's the type of thing that we envision being communicated in the resident manual. And so saying, this outlet, this red outlet or whatever you want to call it, is what has emergency power. These are the types of things you should plug into that. Don't go plugging your window AC into that because, this system was sized to provide power for everyone during this event. And if you do, if you plug in your window AC units and everyone does that, we're going to drain the power and we're going to be without power, right? So communicating those types of operational considerations would fall into the emergency management procedures manual, which for now, we've left that up to we've effectively required the design team to develop that and hand that over to ownership with areas for the ownership or development team to fill out in how it overlays with their building operations procedures.
Yeah, and just for folks that don't know, like the talking about red plugs, if you've ever been in a hospital room or doctor's office, you may see one plug that's red. And the reason that one's red is because they know that when there's a power outage, that one will maintain electricity. So that's one model that could be carried over for this as far as noting that. So, and I will say to Ben, who submitted this, and to everyone else, I would love some feedback on the duration requirement and submit comments around that, because we would love to get more feedback on that. All right. Yeah, I was just on a call with an affordable housing org that was lamenting about elevator backup power being a challenge for solar and storage. Did the research look into that backup requirement impacts, how that backup requirement impacts building loads? This is a great question. I will say we didn't specifically look at that in this. Clean Energy Group, we've been working on affordable housing and just resilience for community serving facilities for over a decade. And elevators are a problem. They're a high power device, and they can increase the cost of storage because you need that extra power. Sometimes, again, that's where a generator or sometimes even a fuel cell can come into play, or a CHP unit, combined heat and power. So that it can be challenging. We have worked with facilities that have been able to manage it. The cost of batteries have come down a lot in 10 years. That doesn't mean it's inexpensive to do. It is possible, but it does create extra cost. That extra power requirement can be difficult. See, did you have any pushback from local jurisdictions regarding enforcement, lack of training, different than what is required, et cetera? So, Tristan, I don't know if you have any thoughts on this. I would say, from our feedback so far, we haven't run into this, but I would say it's not something that we've really delved into deeply at the time. Again, just based off of a decade of experience in this, it varies from jurisdiction to jurisdiction. A lot of folks are still very unexperienced in energy storage. So not just from the code side, but also things like fire departments. There needs to be a lot of education there with folks so that they understand and can have the appropriate folks up to speed on what needs to be in place and how to do that. So I do know, Tristan, maybe you can speak to this more. I know, there's a lot of talk about need for more training for code enforcement folks.
Yeah. The people we have been talking to, obviously cost is a big concern, especially when we're talking about this potentially being a mandatory requirement across the board. We've seen comments reflecting that here today and questions about that. We are exploring and in conversations with folks and trying to move forward with some pilot projects that would build according to the code so that we can understand what are the first incremental first costs, and also have a team work through with us and with technical assistance how to comply with this and where pinch points are so that this can be refined and improved over time.
Yeah. So, noting that we are starting to wind down on time, I'm going to pick and choose just a little bit. No offense to folks, so just there's certain ones I definitely want to get to here. It's a question, does Connecticut provide incentives that developers could use for this program? And what possible incentives are there? So Connecticut has two things that are great for this. One is a residential solar program where multifamily affordable housing is considered residential under that program. That's the one where the solar benefits are shared with residents as well for individually metered buildings. They also have what's called energy storage solutions, an energy storage program, where not only do you get upfront incentives, particularly for low income serving projects, but there's also a performance incentive for discharging the battery during times of peak demand, which actually lowers costs for everybody in all rate customers in the utility operations. So they have some very good programs for this. Some other states have things like this, like Massachusetts does as well. Vermont has some good programs. California has some good incentive programs. So there are a number across the country. There are a lot of places that don't have a lot of incentives for this. So it really depends on where you are and how applicable or how cost effective this will be based on the incentives that are there. There are some federal programs. Solar for All may be one aspect that you can look into. That's in every state, but that hasn't been really rolled out yet completely. So there are hopefully going to be some federal avenues for paying for this as well that will be available across the country, although it'll look different from state to state. And Tristan, if you're reading the questions too, please feel free to jump in. I see there's one specifically asking like why certain things were used as a basis for the code.
Yeah, so we used the 2021, I believe the 2021 IUCC, which is what the current Connecticut energy code is based off of. And so that was our baseline for evaluation.
Great. There's a question of, would there be incentives for different levels of compliance with the stretch code, or would it be an all or nothing approach? That's also a good question. And I think it will depend on how this is ultimately rolled out. Right now, it's kind of written as a all or nothing. But some of the measures will clearly be very difficult for existing buildings without a deep retrofit. So one of the things that I would like to explore, and I have yet to talk to the full project team about this, is some of those alternate compliance pathways where you could implement, say, maybe some of the backup power requirements without doing a full building envelope, and the feasibility of that for existing buildings in particular. So I would say that's to be determined, and would love some public comments on that as well. Would be super helpful.
And I can answer two questions. Someone asked if we can share the expansive straw man. I don't think I have a problem with that. We can find a way if you're open to that, Seth. And then
Sure.
a couple people asked about other related things. That straw man included a lot of resilient stuff that much of it was outside of the scope of this project. I would say urban heat island stuff made it in as kind of a tangential, looking at providing backup to things like pumps for water supply was sort of tangential, but fell into critical systems. Things associated with flooding, for the most part, were not included. We did add a requirement, which I see someone asked in here. We did add a requirement for the location of equipment to make sure that was above the 500-year FEMA floodplain or another flood consideration as established by the authority having jurisdiction. So a lot of stuff, a lot of spaghetti went on the wall with the straw man, and we had to narrow that down over time. But NBI is engaged with a number of efforts looking at, resilience broadly, covering a range of resilience and hazard categories.
Great. Well, I see we're just over 2 o'clock, so we're a little bit over time. Thank you, everyone. Thank you, Tristan. This is, I hope everybody has found this to be educational, and please do take a look and provide comments. You can even provide them directly to my email address here, seth@cleanegroup.org. So thanks all for tuning in, and do reach out if you have any additional follow-up questions or things we didn't get to today. And with that, I'll turn it back over to Zareen for any final thoughts.
Thanks again, everyone, for coming. We have a couple upcoming webinars you can see here on your screen. If you'd like to sign up for those, you can do so at cleanegroup.org/webinars. And just as a reminder, this webinar has been recorded, and the webinar slides and recording will be sent to all of you 24 hours after the webinar has ended. So thanks again, everyone, and have a great afternoon.